Okay, next part is asymptote. Okay, 8.2 for the chapter 8 is asymptote. Alright, so we have two types of asymptote, which is vertical asymptote and horizontal asymptote. Alright, so first we're going to look how to find vertical asymptote, okay, for any function of x. Alright, so vertical asymptote, okay, if we want to find the vertical asymptote, okay, so before that, okay, asymptote is a line that appeared in graph but not exist. Okay, so asymptote ni dia ada dalam graph tapi dia tak wujud. Okay, for example, for the function reciprocal, so fx equals to 1 over x, for example, we know that the graph is something like this. Okay, and it has both asymptote. Okay, it has a vertical asymptote at the y-axis. Okay, this is vertical asymptote, and it also has a horizontal asymptote at x equals to 0. Y equals to 0, or at the x-axis. This is horizontal asymptote. Alright, so the vertical asymptote is y-axis, or this is equivalent to x equals to 0. Alright, so how are we going to find the asymptote, okay, for any function? And asymptote is not in the graph, okay, but it's just a guide, okay. Dia tak ada dalam graph ni, dia cuma panduan lah kepada kita apabila kita sketch the graph. Okay, the graph will not touch the asymptote, it's just only getting closer and closer to asymptote, but never reach that point. Alright, so to find vertical asymptote, what we're going to do is we need to find, okay, limit of x approaches a okay, from the right, and also x approaches a from the left, okay, and we want to see the limit, okay, become infinity or not. Okay, we want to see the limit become infinity. If the limit is if equals to infinity, that's mean x equals to a is a vertical asymptote. Alright, so the problem is, what is a? Okay, dari mana datangnya a ni? Okay, so a is from the denominator. Okay, so a is from denominator. Alright, so to get more understanding, we're going to discuss an example here. Right, so we take a look at example 20. Okay, so we want to find the vertical asymptote for this function, which is x plus 3 over x plus 2. So that's mean we're going to find the limit of x approaches a from the left. Okay, which is x plus 3 over x plus 2, and also the limit of x approaches a from the from the right. Okay, x plus 3 over x plus 2. Okay, what is a? So like I told you before, a is from the denominator. So denominator for this function is x plus 2. So we take x plus 2 and we equate equals to 0, and we try to solve this. So we get x is equals to negative 2. So negative 2 is our a. Okay, so that's mean we're going to find limit of x approaches negative 2 from the left and negative 2 from the right. Alright. Alright, so first we do for the approaches negative 2 from the left first. Right, so if we substitute directly the limit, okay, so if I substitute directly the limit, so negative 2 plus 3 over negative 2 plus 2, so we will get, okay, 1 over 0, and we already discussed in the previous topic that if we get a number over 0 in limits, this is approach infinity. And also we can determine whether this is positive or negative infinity. Alright, so for this question, this is equals to negative infinity. But we didn't bother about what either it is negative or positive. Okay, just if we get infinity, that's mean this is a this is okay. Okay, so kita just nak tahu dia jadi infinity ataupun tak, itu je. Right, so the same for the limit of x approaches negative infinity from the right. Sorry, this is from the right. So if we substitute the limit, so we have negative 2 plus 3 over negative 2 plus 2. Also the same, we get 1 over 0. And this is equals to infinity, or this is as positive infinity. Alright, so now we have what we want. So if we get infinity, so that's means, and we can write the conclusion is, okay, the conclusion is x equals to negative 2 is a vertical asymptote. Okay, right, so that's how we find a vertical asymptote. Right, so we're going to look, okay, another example here. Okay, we have a lot of example here. Alright, so number 2 or B. Okay, we want to find the vertical asymptote for the function 1 over x minus 4. Okay, so we need to find the limit of x. So limit of x approaches a from the left. So for this question, a is, okay, we take from the denominator, which is x minus 4 equals to 0. So x equals to 4. Alright, so a for this question is 4. So we need to find the limit of x approaches 4 from the left. Okay, 1 over x minus 4. And also limit of x approaches 4 from the right, 1 over x minus 4. So if we substitute directly the limit, which is 4, we get 1 over 4 minus 4. Okay, this is 1 over 0, which is infinity. Or to be exact, this is negative infinity. And for this question, okay, we get for this limit, if we substitute directly, we get 4 minus 4, which is 1 over 0, also infinity. Or to be exact, this is positive infinity. So from the left we get infinity, from the right also infinity. So that's mean x equals to 4 is a vertical asymptote. Alright, so that's how we find a horizontal asymptote. Okay, C. Okay, we want to find the vertical asymptote for this function, 2x over x squared minus x minus 2. Alright, so from the denominator, okay, x squared minus x minus 2, if we equate equals to 0, so we can factorize this. This is equals to x minus 2 times x plus 1 equals to 0. So that's mean x minus 2 equals to 0, or x plus 1 equals to 0. So x equals to 2, x equals to negative 1. So we have two value of x here. That's mean we have two a's. Okay, that means kita ada dua a lah di sini, which is 2 and negative 1. So that's mean we need to find four things here. Okay, which is we need to find the limit of x approaches, okay, 2 from the left and 2 from the right. Okay, alright, so for this question, if we substitute directly the limit, okay, 2, so we will get 2 times 2 over 2 squared minus 2 minus 2. This is equals to 4 over 0, which is infinity. Okay, so the same here, if we substitute directly, we get 4 over 0, which is also infinity. So that's mean x equals to 2 is a vertical asymptote. Right, so that is for our first value of a, which is for 2. Now we're going to check for second a, which is -1. So we need to find the limit of, okay, this is 4, a equals to 2, and now we're going to check for a is equals to -1. So we need to find the limit of x approaches -1 from the left, and also limit of x approaches -1 from the right. Okay, so if we substitute directly, okay, the value -1, so we get 2 times -1 over -1 squared plus -1, okay, minus 2, sorry, not plus, this is minus x. Okay, also the same here, minus x. I accidentally changed the sign here. Okay, minus x. Okay, so this is also minus. Okay, so what we get here is -2 over 0, which is infinity. And this is also, we get -2 over 0, which is infinity. Okay, doesn't matter that is positive or negative infinity. Just if we have infinity, that's mean, okay, for this, for a equals to -1, x equals to -1 is a vertical asymptote.